Hi, this is Nectarios Georgialas from British Telecom, and I'm leading this catalyst on smart cities, which exhibits BT's approach in how to manage and monetize smart cities with the data hubs, smart city data hubs. This is the second iteration of the catalyst. We had already last year, the same catalyst, but we only introduced the idea. This year, we're doing some more cool stuff with the data hubs, which I'm going to go through in a minute with you. First, to provide, to acknowledge our participants and our key contributors to that. There's a big team of background and foreground players that contributed to this catalyst. So BT is the leader and done the leading development of the project. We have Milton Keynes, which is the city that all this technology gets deployed into. We have Enrica as a sponsor to the catalyst because they're quite interested in the ideas to be deployed in the Smart Energy Initiative in America. We have Open University as well as a sponsor to the catalyst. And key contributors are Cloudsoft, very important, Infonova, and Huawei. So a few words just to contextualize the story. All the technologies deployed in the UK city, Milton Keynes, the UK is a very vibrant UK city in the UK, which actually looking into the future is going to grow with quite significant rates of 60% by 2026. And the thing they want to understand is how they can use better their infrastructures to be able to respond to these growth rates without actually having to spend loads of money in investment. And the only way to do that is actually understanding a bit better, like the nervous system in the body, sensoring up the city, how the city utilities infrastructure is used, how the people are running their life, what other people's habits, so they make sure that they can optimize resource usage. So they started the project of MK Smart. BT is a leading player in that in this project. This is a real use case, and that's how the story of data hubs came in. What is a data hub? A data hub is the way where we can actually collect all data feeds from the sensors in the city in one solid place, one point of reference. We aggregate the data. There's a component architecture, as you see in the slide, that enables that. So data feeds come from the bottom on the left-hand side. It can be provided from sensors. It can be provided by information providers, so they can dump the data into the data hub. And then there is a whole set of components in the data hub that makes it, that enables a whole ecosystem of partners trade the data. So providers offer the data, consumers consume the data. There's application developers who actually use the data feeds in order to develop innovative applications. So another key aspect here is innovation. What's more, we use Infonova's R6 platform for ecosystem enablement, which allows us to introduce very complex relationships, commercial relationships, to sell the data. But I'll point to my colleague Nico Mueller later to explain how this happens. So let us just kick off with what we're doing in this catalyst. That described last year's catalyst. In this iteration, we're working on SLAs and Trust. So the data hub is a good effort, but it was best effort. It was a desirable approach. Now, companies and SMEs that develop applications want to make sure that they can depend on the data hub, the data feeds coming out of it, to develop mission, business, and operation critical applications. So to do that, they need guarantees of data quality. They need to make sure that what the data hub promises them to receive, it will come to them, and therefore the application deliver their goals. Because there's money on the game, they bank the money on the game. If that doesn't happen, then they need to make sure that they're refunded, and the responsible for this are held accountable for breaches of SLA. So we dress everything up with SLAs, and we dress everything up with trust, privacy, and security to make the data hub trustworthy. How do we do that? There's two end-to-end stories here that I'm going to go through very quickly. This is the end-to-end picture of sensors infrastructures in the city at the bottom right-hand side, data feeds coming out of them into the data hub, and on the top left hand side you see consumers with applications or application developers consuming those data feeds. The SLA is building up in layers. The SLA enablement builds up in layers. This layer actually allows the data providers to dress up their data feeds with different classes of service. The example we implemented in the Catalyst talks about car park availability, saying we can offer, for instance, a bronze service of the data feed, which provides us historical data with 24 hours latency, and we can actually offer that for free. There is a silver service that the data provider can decide to charge based on a plan A or X pounds, which gives us 1 data point per hour, and a gold service that provides the data to us in a bigger frequency, like 1 data point per minute, so more real-time view of what's going on in a car park. That way, the data providers can charge appropriately based on the resolution of the data, providing better quality, charging more for it or less for it. The next layer of SLA is all about the data hub itself doing analytics on the SLAs. We can see how the feed responded and the class of service on the feed responded in the past 24 hours. And that is something that a consumer wants to check to judge the reliability of the data feed before they commit to buy it, to commit to subscribe to it. So we do analytics, and in case the SLA is breached, we have a monitoring, service monitoring capability, horizontal one that monitors the health of all the components and data feeds in the ecosystem. If there is an SLA violation that the monitoring facility catches, then InfoNova's 6 comes in to issue and account for this breach, in terms of monetization. So it calculates rebates back to the customer for the data loss. It calculates compensation to the customer. It has to penalize with a fine the responsible authority that caused the SLA violation. Another layer of SLA has to do with the data hub itself being a functional and operational entity, a group of components that run, and because we have to make it highly performant and highly reliable, we need to make sure it can scale up and it's of high availability. So working with CloudSoft here to make sure that the data hub becomes highly resilient. Working again with CloudSoft, we also take care of SLAs at the customer application layer, which we can host on a data center next to the data hub. An example here could be, we want to run analytics applications, and usually that happens when you bring the logic, the analytics logic next to where the data is located. So we assign priorities. Higher priorities use the premium resources. Lower priorities applications would have to actually spin out to other cloud services like the BT Cloud Compute one in other locations to offer the premium resources for the benefit of higher priority applications. And we call that contention management. At the same time, we do auto-scaling and other kind of SLA requirements for the customer applications. The trust part of the story, the privacy and security, we're working with Huawei using their IoT platform, which actually is highly secure. It allows handshaking of devices within the platform to make sure that only legitimate devices can collect data. We add another layer of security when the data feed comes into the data hub to make sure that only whitelisted devices can subscribe to the feeds in the data hub. In the data hub, when the data provider offers their data, they can assign terms and conditions that define how the data is to be used. So the data provider imposes rules of the game, and the data hub in operation would have to enforce those rules. And the same story goes at the customer's layer, which means really that only authorized customers, consumers, can access the data feeds that they're allowed to access. So that way we have an end-to-end SLA on one hand and trust and privacy and security story on the other hand. And now I would like to hand over to my colleague Nico Mueller from BearingPoint to explain how the R6 system enables the ecosystem around the data hub.
Thanks, Aris. So I will explain a little bit about what is BearingPoint InfoNova R6 doing in this project. BearingPoint InfoNova R6 is a digital ecosystem management platform that provides various OSS and BSS, a full OSS and BSS stack from order management, billing management, invoice management, customer management, everything that comes with the OSS BSS stack, and enables a smart city or another digital ecosystem to be monetized. We at BearingPoint think that it's very important that you create a sustainable model and give an incentive to industry to come on board in such a project. Milton Keynes is a perfect example of how such a sustainable model can be created. So what we did in this catalyst, and what was the extension from the last year's catalyst about Milton Keynes, was that we added SLA breach detection and how to handle SLA breaches. So what we can see on this slide is how a data flow gets monetized, and we see how a breach results into the various parties getting a credit or a refund automatically via InfoNova R6. So it was great working in this project. We hope that we can share this model that is presented on the slide, which shows the value gain from a data flow monetization to the various parties. And it was great working with BT and the other parties on this project.